All right, let's go ahead and get started for real. Welcome back to class. Hi, everybody. How are you all doing today? Good. I'm waiting for it to be warm again. Something I need to announce, I will not be holding office hours today. My office hours are normally this afternoon. How many of you are planning on coming and seeing me? At least one, two. If you're planning on coming and seeing me, send me an email and we can find a time either tomorrow afternoon or Monday. Or if it's something that's like super time sensitive, just let me know and we can work it out over email. Does that work for you? Is that okay? Good. Anyone else? Anyway, so I won't be at my office hours this afternoon. Last time we started talking about stuff that's fun. And we are moving from an imperative programming paradigm into what? Object-oriented. And what's the basis of object-oriented programming? Classes. What is a class? We have a visitor from Stanford today, and I won't pick on him right now. But what is a class? Anybody remember what a class is? It's a group of students sitting, staring silently at a professor, not saying anything. Yes? Yes, it is a collection of data and functions on that data. So what we're doing now is we're trying to conceptually take a whole bunch of data that represents something in our program and package it together. And since we're packaging that together, there's no point in having separate functions about it because the functions would only work on that data, so we're sticking that in there too. Okay? So a class is a bunch of data. It can be any type. Classes can be have classes within and functions that we work on that data. When we have a function that works on that data, well, let's see, maybe I have that. Okay, the interesting thing about a class is it is actually the blueprint. Like when we write the class, we are writing a blueprint. How do we actually get, what do we get when we create one of these classes? An object, and how do we get an object? When we instantiate a class. So the easiest way to instantiate a class is just to use its name, right? Like last time we were working with the person class and we just said person and gave it a name and then we had one, like magic. We'll see other ways to do it later in the semester, but right now you can just call it by name. Okay, what is a method? Yes? It's a function that is part of a class. Instead of, here, sorry. I probably should give you some warning. Okay, it's a function that is part of a class, all right? So when we have functions that are by themselves, we call them functions. When we have a method, we just use that so we can charge more when we build people and have fancy words they don't understand, and to indicate to each other that this function is actually part of a class. Inside the class, we have things that are public. What does public mean? Sir? Yep, everyone can see it. A method that can be accessed or a data member that can be accessed directly just by using dot and then the name of the method or the name of the thing. Would you like a candy bar too? I'm trying to get rid of these because I've been eating too many of them in my office and I don't want to have them around anymore. So, private, what is private? Yes? Things that are not intended for outside use, and where can you actually call and use these private things? Exactly, only within the methods of the class. So you have a method or a data member that you can only refer to directly inside there. And we saw what happens if you try to access something that is private from outside. What happens? The compiler gets upset and yells at you, like it likes to do. We have a constructor. A constructor is a type of method. What type of method is it? When do we use the constructor? We use it for initialization, and how do we actually call it and get it to fire? And it gets called automatically, yes. It is a method that's called automatically when the object is instantiated. So the moment we create one of these objects, this method, the constructor method, gets called automatically. All right? It just happens. Normally we use these constructors for initialization of values inside there. That's just the general case in general. Sometimes you use it for other things, but for us, mostly what we'll see is we use it for initialization. All right, so there we are. That's our refresher of where we were. Let's go look at some code. So last time we were talking through this, this person class. Sorry, the screen resized. Let me see what I can do here. All right. So last time we were talking about this person class, and if we go back and look, we had some public data members named Mood. This is public data. Normally we don't do that very often, but we had it there to show that it can be used. We had a constructor that had no return type, and an overloaded constructor, meaning that it could take a string. And what we were using this string for was to set the person's name when we created things. Everybody back? Remember this? And so these two constructors did things slightly differently. The constructor that didn't take an argument set their weight to 0, it set their gender to just kind of an empty value, and it set their mood to happy. Okay? And then we were showing how inside the constructor, if we passed a new name, we could set the name to new name, and we were trying to call this other constructor. And do you remember this? It didn't work. Yeah, this sucked. Okay, here's my excuse. This works in Java. And I've been doing Java programming recently, so I thought this was going to work. It doesn't work in C++. And I will just confess right now, I suck. Okay. All right. So what we were trying to do is we were trying to have a constructor where we set the name, but instead of duplicating all this code down here that set the weight, gender, and mood, I tried to just call the constructor, and this other constructor would do all that. You can do that in Java, but you're not learning Java, right? So I suck. So we have to do something else. And so the other thing that we can do instead is just cut and paste the code, which I don't like to do very much. Oh, come on, stupid keyboard. So my editor upgraded itself, and when it did that, it reset all my key settings, so which is really annoying. Okay. So instead we'll do this, we'll just copy stuff over. Okay. And now we have constructors that will set things with name or will set things without name. Right. Everybody with me? I'm sorry I screwed that up at the end of the class. That's what you get. It would be like I was teaching Spanish and I accidentally taught you the Portuguese word for something, and it didn't work. How many people did I lose? Yes? No, you can't call another constructor within a constructor. You can call other methods. Methods are fine, it's just that you can't call constructors. And that's kind of a lie. There's like a new version of C++, that's the 2011 version, that the spec is from 2011, and they come out with a spec, and then it takes a few years for the compilers to catch up. And there is a way you can do it in the new compiler. It's just not worth going into the detail for that. So we're just going to pretend that we can't do it. Yes, sir? Yeah. Okay, so we have two separate constructors. One is a constructor right here that takes a name as an argument, and one is a constructor right here that doesn't take a name. It just doesn't take any argument. And what happens is the compiler can tell these apart based on which one is used. So if we look down at where we're calling these things, right, here we declare a person named X, or a person that's placed in a variable name with X. And what happens is it looks at it and goes, oh, I'm creating a person. And there's no parentheses after the X. I'm going to split the screen in two here so we can follow and watch both things at once, right? So we have a person that a variable of person type that has name a value, an identifier of X. And what happens is it goes, okay, I'm making a person. Did they include a name for this person? They did not. For person X, it just says X. There's nothing. So what ends up happening is it calls the constructor that takes no arguments. With me so far? Then down here we call this other person Y, and is there a name there? Yes, there is, because there's Fred in there, and so it looks and it goes, oh, this one has a name, I will use this other constructor. So the compiler is able to tell methods apart even if they have the same name, because they have different parameters. And as long as every constructor has different list of parameters, it can tell them apart. And the question is, which one do you use? And the answer is it depends on your object and how you're creating it. So, yes?
So can you have two constructors that both call a string?
No. You can never have two constructors that both call a string because the compiler can't tell them apart. You can have a constructor that calls one string and a constructor that calls two strings. That you can do because it can differentiate between how many things and how many different parameters and their types it takes. All right, who did I manage to confuse by doing things wrong and then jumping right back into where I was wrong? You can admit it. Yes, question?
For the new name, do you have to put the weight, gender, and mood?
No, you don't have to, but the idea behind this, the constructor, is that we want to initialize everything, right? So in our constructor, we can choose what we want to do. It's good practice, just like we saw about initializing our variables before, it's good practice in your constructor to initialize things that need to be initialized, okay? So, you know, we notice that down here for person, we didn't initialize the name. And we didn't initialize the name because the name is a string. The string has its own constructor. When it gets created, it automatically initializes itself. So we didn't have to initialize that. Weight, we kind of had to initialize. Gender, we had to initialize. Mood, we put as happy just because we want people to be happy, don't we? And we could change that to, you know, depressed or something like that if you wanted, if we didn't want people to be happy. But does that make sense? Okay. So constructors, there we are. All right, everybody with me on constructors? Now let's run this code and just see what happens again, just to make sure we haven't introduced any errors here. And what we're doing is we're creating a person, looking at their mood, setting their mood to something else, looking at it again, checking their name, creating a new person that actually has a name, getting their name, and then checking their mood. Okay? No, don't do that. I almost overwrite our C++ file. Okay. So, the person constructor is called. We saw that. The person's happy. They're sad. They have no name. That's that blank line. Then we call the other constructor. Whatever constructor is, we call that with Fred, and they're happy. So, all right. So the whole point of this is to see that when we have an object, the constructor gets called automatically, that you can have different constructors that get called depending on what the parameters are, and you can use them in different ways. Okay? Now, the question is probably on your mind is, please tell me which one to use when, and the answer is, it depends on your algorithm and what you're trying to do. I don't have a hard and fast answer for that. Questions so far? Nothing? All right. So, because I'm a computer scientist, I think about things in terms of binary. You either have something or you don't have something. It also means if you have something, you have the opposite of something. We have a constructor. Anybody think we have the opposite of a constructor? A deconstructor or a destructor is what it's called. So, we can also have something that's called a destructor. Okay? And if a constructor gets called when the object is created, a destructor gets called when the object goes away. And when do things go away? Nope. If you make them 0, you've just changed their value. They haven't gone away. Pardon? When you clear them? Well, the only clear that I remember we've seen is for vectors, and that's a method of a vector. That doesn't make it go away. How about this? Anybody remember scope? We talked about scope a few days ago. Yeah? So what happens is variables go away when they go out of scope. So if you have a variable, you have a parameter and a function, it exists only when that function is being used, and then after that it goes away. So what we're going to do is we're going to see a destructor now. And the way we know things that are a destructor is they have a tilde in front of them. That little squiggle, that is the key on the uppermost left of your keyboard with a shift, tilde. And here's what the destructor is used to get rid of things that you might have created with the object. And right now, we don't have a good example of that. We're not actually doing anything we need a destructor for, but I just want to introduce you to the concept, so let's put one in here and see what happens. All right. If we want to have a destructor, we have to say person, because it belongs to the person class, and it is a destructor. And all we're going to have this right now, and again, I'll put a note here, destructors. I like putting this note in here because otherwise what happens is, like, later when you're studying for the exam, you'll go back and look at your exam and look at all the constructors we've written that have output statements. And then on the exam, every time you write a constructor or a destructor, you will print things out thinking the way that it's supposed to go. But it's not. It's just for demo purposes only. So now we've added the destructor for the person class. Let's compile it and make sure I didn't screw that up too badly. I didn't. And now when we run it, here's what we should see. If we go back and look at the old output, we saw that a person constructor was called. They were happy, they were sad, they had no name, that was blank. We called a constructor with a name, Fred, they were happy, and then the person left. In fact, you know what I'm going to do? I should have done this story. I'm going to actually output the name of the person we are destroying so that before they go, we can see which one is getting destroyed. Okay. Everybody with me? Constructor gets called automatically. Destructor gets called automatically when things go out of scope. So we'll compile it, and we'll run it. And you can see first we're destroying person Fred. This is the first one we called. And second, we're destroying person with no name, which was the first person. All right, so the question you might have is, when do you need a destructor? And the answer is, you don't need it right now. Later we will need it. I just wanted to show you that it happens. Constructors get created automatically. Constructors get fired off and used automatically, as do destructors. So, all right, questions so far? Yeah? It means Fred went out of scope and it went away. That's all. So it means that we can no longer, when the variable is destroyed, everything that's in that memory is gone. We can't get it back. And we can never look at it again, essentially. But it means the program was done using it, and because it was done using it, it got rid of it. So remember, every time we talk about a variable, we have a box in memory. Right? Remember, like day 2, we started talking about that. Everything was a box in memory. What's happening when we instantiate an object is it's creating a big box in memory that can hold all the different pieces. And when we're destroying it, it says, hey, we're not using this memory anymore. We can give it up. We can use it for something else. Okay, so it's reclaiming the memory space. All right, how's everyone doing? Good? Do you want to stand up for 1 minute and stretch? All right, let's just sit there then. Oh, you do want to stand up. Okay. 1 minute break. Yep. Yeah, I posted last week's code on there, and I'll post the other day. Yeah. I mean, I didn't post multiple versions of it, but. Mm-hmm. All right, let's start back up. One thing I do want to show you. Do I have to separate you two? Okay. One thing I do want to show you that we haven't seen yet is a private method, okay? We've seen private data members. Let's actually make a private method. And this method is going to be a method to set the name. And the idea behind this is that we can use this method to change the name of the person if we want, But not just anyone can change the name. All right? Not just anyone can change the name. So here I've declared this method prototype in the private section. I've called it setName. This is an accessor or setter. Method. And it allows us to change the value of something, but it's private. So let's say we want to change the name. We'll go down here and we have to create the method for it. We say it's void. Did I put void in there? Yes. We put void. We say it's setName. We have a string. The string is the new name. And this is pretty easy. You say name equals new name. All right, everybody with me? All we've done is create a little method. Oh, except what did I forget? I forgot to say which class it's part of. So person setName string new name. And what I'd like to use this for is I feel bad for this first person we created that doesn't have a name. People should have names. So we can just say x setName, and what name should this person have? Lars? Is that what you said? All right. So here's what we're going to do is we're going to give this person the name Lars, and we'll see that it worked. Okay. Now, is this going to work or not? How many of y'all think this is going to work? How many of you think it's not going to work? Why is it not going to work? Because it's a private member. So what we're trying to do is we're trying to set the name, and let's see what happens when we compile this. setName is a private member of person. Not just anything can come along and change the name. So if we can't use it there, where can we use it? Pardon? In the class. And so what that means is that what we can do is we can go back up here and we can change our constructor. And so what we can do is in here we can say setName, and we can tell it to give it the name that we were passed, and it will work. Okay. So I just went really fast for that, and I should go slower. But what I was trying to show is that down here you cannot use. Can't use this. I'm going to comment this out. All right. This line will not work because setName is private. The only place we can actually, and this is outside the object, and we know it's outside because we're using the name x and dot. We cannot call a private method that way. Everybody good with that? Now, where can we use it? We can use it somewhere inside here. So for example, I change the constructor to now call the setName method. All right. And now the program's going to work essentially the same way as before, except now instead of changing the name directly in the constructor, we're calling the method that changes it. Now, how many of you are wondering why the hell we're doing it this way? How many of you are kind of lost the thread and not sure where we are anymore? Okay. So just to review where we were, what we're talking about is we have a class. Everybody good with the idea of classes? And classes have methods that are functions that operate on the data inside there. Everybody good with that? Can I have some feedback? All right, show of hands. I want everybody to put their hand up, and I'm going to start describing concepts. And when I reach a concept that you are not familiar with, I would like you to take your hand down. Okay? This is like negative hand raising. Okay, so we have classes. Classes get instantiated into objects. Classes have in them data members, which are data. Classes have in them functions, which are called methods. Private methods cannot be called from outside the object. Public methods can be called from outside the object. Methods can call other methods. A constructor can call methods. Okay, well, that didn't really prefer either. So, all right. So here's what we're happening. I'm just showing you a different way of doing things, right? And I'm going to tell you why in one sec. Okay. previously, we had done this, name equals new name. And which name was this? Like in terms of what, when we're setting this equal, how do we find out what name this is? Sir? Okay, so we talked about scope the other day. When we see a variable, what do? We see name. We look right back up and we go, is there a locally defined name? Is there a local variable inside that block named name? How many of you think there are? How many of you think there are not? Okay, there is not. Then we look at the parameters and we say, is there a parameter named name? There is not. So there must be name someplace else. So here it's either global or it's a private data member, because when we're working inside a class, the scope includes the data members that are part of the class. And is there a data member named name? Yes, there is. So we're able to figure out when we say name equals new name that we're mucking with this one up here. Yes? Why is it I can change it? It's because the name is private, which means that you cannot change it from outside, which meant we could not do this down here, right? Because the set name was private. And we couldn't do just .name either, because that's private as well. But the way these objects work is we want them to be able to do some functionality that is all their own, right? That is all their own, to provide services outside the object. So if I can go back to the bank example, right? We want you to be able to get your money out of the bank, but we don't want you to be able to get all the money out of the bank. So we provide an interface, which is like the teller window where you go and you say, here's my money, and you're giving me my money, and they say, here is your money. And if you have a gun, you can go and say, give me all the money, and they will say, here's all the money and an exploding die pack and a nice visit to the jail at the same time. Okay, so what I've done here is I'm just trying to show you two different things. These are both ways of doing the same thing, right? Name equals new name just works because this is part of the person class. It has the person colon in front of it, so we can just change it. Set name also works because even though it's a private method, like right here, name equals new name is like private data member. Set name is like a private method that we can call, and they both end up doing the same thing. Now the question is, why the hell do we care, right? Like if the first one works, why do we do the second? Because it's inside one of these methods that starts with person colon colon is the answer, right? If it's inside person colon colon, you can change the things. You can change the private data members. The private data members have to be changed. It doesn't do us much good to just create something that never be changed. We're just limiting when and where it can be changed. Question? No, it's not just that it's outside of int main. It's actually in a method that the name of which starts with person colon colon or the class name colon colon. Well, when you start talking about multiple classes, other classes can't reach inside. So if we had if we started with a person class and then we had a lot of people and we called it a mob class and we had like a mob couldn't reach in and change individuals' names. Yep, any of the methods that start with person colon colon can change any of the private data members or call any of the private methods. Okay. All right, everybody with me now? More or less? How many of you more? How many of you less? How many of you the internet is much more interesting today than me? All right, so I'm just going to keep going. Absence of feedback means I'm doing something right to me, okay? All right, so we're doing the same thing two different ways. We have a method and we have just a direct access. Why do we want to ever have a method to do this? Yes? Yes, so you don't have to rewrite the entire method every time you use it, and that's a good point, and there's one other thing in there. What are we not doing with our data right now that we're putting in there? Yeah. Checking for errors. So here's what I want to do. I want to actually add another thing here called set weight. And this is going to take a double, okay? This is a private method, and we're going to also, when we enter the person's name, when we set the name, we also want to be able to set the weight, okay? So hang on, let me just take one of these out because we no longer need it. All right. So let's go down here, and we're going to write a method that actually does some error checking. So it's void because it doesn't return anything. It's person : because it's a function that belongs to the person class, making it a method of the person class, and it's called set weight. And it takes a double, which is the new weight. Okay. Now, what do we know about people's weights? Pardon? It changes. Yeah, we might have to, if we really wanted to model a person, we need to change their weight over time. But can we say anything about the range of weights? Yes? Sure. I mean, the upper weight we don't know, but we can definitely say it's greater than 0, right? In fact, it's probably greater than, I don't know, like 1 or 2, right? I mean, there's some lower limit on how survivable it is when you're a baby, and I feel really horrible talking about weight in this way, but it's kind of true, right? So what we can do is we can say something like if double is less than or equal to 1, assuming we're working in pounds, right? Then there's a problem. Or we can say if double, and let's just say we're working in pounds, is double. What am I writing there? New weight. Sorry. Have I complained recently that public speaking is hard, but public speaking and coding at the same time is even harder? Right? So if new weight is like greater than or equal to, say, let's like, I don't know, 2,000 pounds, then something has gone wrong. Now, what you actually do here depends on your class. Right now, we're just going to output something and say, see out something like how about this? We just say, I don't know. I don't even know what's reasonable here. We'll just make it 0. All right. So now what we're doing is when we set the weight, we can do some error checking right on the spot. Okay? And we can figure out what to do in the event of error. This, is not necessarily the best way to handle it, but it just shows you can do it. A person class that we're working with now is actually something that's very simple. Like the classes get much more complex. And you can imagine that for more complex classes, like say, one of the objects you got handed was a vector of all the zip codes in the United States, and there's several thousands of them. You could, in your method, go through and verify that all those were reasonable zip codes, right? Whatever your object is, you could go through and make sure that was reasonable. All right, everybody with me? Yes? Yes? Because if you don't have the else, if we just had the weight, it would set the weight to 0, and then after that, it would automatically set the weight equal to new weight. So if I took the else out and just did this, what would happen is if this weight was bad, it would say, hey, the weight's out of range, let's set it equal to 0, and then when the if statement happened, it would go down and do this statement anyway. Yeah, it would say the weight's 50. You do need the else. Okay, if weight is 50, here's what would happen, right? Let's just say weight is 50. All right, we'll step through. Weight's 50. Is 50 less than or equal to 1? Right, so, but yeah, you need the else. In this case, you need the else. Or the other thing you could do is you could just put a return here. But you need something, You need something to break the control flow. You can do that too. Do you like it that way better? Whichever you like. I actually like that style too, better than else, but they both work. I think the else, in terms of reading code, makes it a little bit more explicit about which thing is happening in which case, because now, yeah, just I don't know. They both do the same thing. Multiple ways to express the same idea. All right. So now we're able to set a person's weight, but it's private. So we have to have some way of doing that. So let's create yet another, constructor that takes a string for the person's name and a double for their weight. And this is funny because I really want to go back and fix some stuff, but I'm not sure it's worth the time. Okay. All right, we'll do this and then I'll go back and fix it and we'll make it better, just because it's bugging me. All right, so in here, what do? We have a new name. How do we set the new name? All right, so we're in the we're just going to print this out. This is, again, atypical. It's only here for demo purposes that we're printing out what we're doing. We will set the name by calling setName. We will set the weight by calling setWeight. And then we still have a gender to deal with. Yeah, this is a horrible way of doing it. But anyway, and mood. Are we still happy? Who wants to go with confused? All right. Everybody with me what we just did? So we created the private method that allowed us to set the weight. In that method, we included error checking so we could make sure that the thing that we were working with was correct. And then we created another new constructor that's different than the other ones that allows us to go ahead and call this setWeight. Okay? And the way it's different, the way it knows it's different is because one constructor has no arguments, one constructor has just a string, and one constructor has both a string and a double. Sir?
So I can't call the method, but I can pass in two parameters.
Yep. Yep. This is called overloading. It's called overloading when you have the same function name that has different parameters. And we'll talk more about overloading. In theory, I should have talked about it before, but the snow days have screwed us up. So I'm, trying to do what we need for the project at the same time. So now if we go down to main, we can create yet another person. And apparently Lars was the choice that we didn't get to use before. And how much does Lars weigh? 700 pounds. All right, well, Lars is a large Lars. All right, let's see. Oh, we've set the weight, but we have no way of getting the weight out. So we better add a weight accessor, right? So do you see how this is kind of annoying that in order to use this object, we have to create all these methods? But do you see all these methods are actually really tiny? And that as we build up the functionality, instead of writing one thing that does everything at once, you can build upon these classes by adding methods as we go along, which is kind of what we're doing. All right, so we'll get the weight, and now that I've declared the prototype, I actually have to write the code. Write it right here, double. This one's pretty easy. And this right here, this observer function, some languages now, this model here with set weight and get weight, where you just set and return the weight, is so common that some languages just have a really shorthand notation where you don't have to write the whole thing out because it gets kind of tedious to do so. But C++ doesn't have that yet. So, all right, so we want to know about Lars. We can see how Lars is, figure out what his name is. We'll see out his weight. 2 semicolons never hurt anything. And we'll just check and see how Lars is doing. All right, when you have extra semicolons, it doesn't really matter. It's like an empty do nothing statement. Yeah, the compiler will probably just take that out. So, all right. Let's see if this works. Gosh, I hope it works. Oh, okay, I made a mistake somewhere. 30. Oh, you know what I forgot? I forgot the function, the method prototype for the new constructor. So. All right. So when we created the new constructor that also took a weight, we also had to create the appropriate prototype for it. Okay. All right, just as an aside, remember when we were talking about functions? We talked about functions could either go before main and not have a prototype, like the book does it, or after main and have a prototype. The reason that I like teaching you about the prototypes is it makes more sense when we get to classes, right? So, because you're kind of more used to it then. Okay, so let's see if that fixed the error. What? Oh, we don't have get mood. We're just doing mood directly. Okay, that's a public data member. So it's unusual to use public data members. It's almost always more common to do that. Okay, so now it should work. All right, and we run this now. We can see in the constructor, Fred was happy in constructor with name and weight. Lars 700, he was apparently confused in that constructor. And then the destructors go off and they destroy each one of the things that we've created as we went along. Okay. Now the question is, what happens if we call something wrong on Lars? Let's say Lars is only 1 pound or 100,000 pounds. Okay. Or a million, anyway. Like 10 million pound Lars. And if we do that, we should get some sort of error. Weight out of reasonable range, making it 0 to indicate error. Okay. May not be the best way to handle it, but that's one way to handle it. All right, questions so far? All right, project 4 is posted. Have you all looked at it yet? I posted it yesterday. I posted something on Blackboard. I actually don't know how Blackboard works for you all. If I post an assignment, I don't know if it like flashes in bright red letters and alerts you, or if you never find out unless I say anything. So, yeah, it's not helpful. I was actually complaining. I was at a meeting yesterday of like the campus faculty IT advisory committee where we get to complain to UIS about something, and I was complaining that if I want to see what you do, I normally run down to the TA lab and try and find someone in my class and go, show me the Blackboard page so I can see what's going on. It's really annoying. All right. So the assignment's posted, and the assignment, what's happened is I've given you a class that's a refugee class. It is not dissimilar from the person class that we have right now. And I've given you essentially the prototype, like the class structure, which is all the methods you need and all the data members. And your job is to go through and write the individual methods. I've also, because I'm an exceedingly nice guy, given you a special main that you can use just to test the refugee class, so that you can write the refugee class and then test it. And then there's also an operation class, which represents the entire refugee operation that has a collection of refugees. Once the refugee class is written and working using that main, then you can actually write the operation class and make sure that works using the other main I've provided for you. Okay? Yes? Really? I thought I fixed that. Can you hit reload on my webpage and then hit project 4? Can you reload the page and try it? Apple R should reload it. Anyway, I'll fix it when I get back to my office. Here's what you can do. Click on project 3. And when project 3 comes up, go to the URL at the top and change the project 3 for a 4 in the URL. And I'll test it when I get back to my office. So I can test it really fast right now.
What do you mean when you said there's another main?
I'll show you. All right, sorry about this. I thought I fixed that last night. It's quite annoying if I didn't. All right, project 3, project 4, go. There, it worked for me. Well. I mean, it should, I don't know. If it keeps not working for you, let me know. But it should work. All right, so here's what I've done is I've essentially given you the refugee class and all the methods you have to write. Right? And they should be similar to what we had last time. And then I've given you the operation class, which essentially implements the things from the menus that you have to do. And then I've given you this main. This main is like you can write the refugee class and test it with this to make sure your refugee class is working somewhat well. And then when you have your operation class, you can test it with this before you write your own main for the final thing. Okay? So, and in fact, we're not doing it for this class. Well, anyway, questions about the project, you can take a look at it and email me. Hopefully. Were you able to get it yet? No? Okay. Yeah, probably you just had the old version, the cached version in there, and it took a sec. All right, so what was I going to say? So the way that we're sort of doing this, and that you have a class and you have a main to test it, is typically how code is actually written in the object-oriented world. What people will do is they will, and this sounds crazy, but it works really well, and I've debated how to teach this to you all. What people often do when they have an object is that they will create all the test cases for the object before they write the object. So they will look at a class and they say, well, if my class works, I know that this method will work this way, this other method will work that way, and they write a whole bunch of code that tests the object. And only after they have written the tests do they actually write the class and test it. And as they're writing the class, what happens is they write something, they run it against the test, and they see whether their class is working or not, and what is left to be done. And it actually works really well because then when you're done, you actually have all your tests done and you know that you have everything right if you wrote your tests correctly. Okay? It's a little bit too much to do for this class, but this gives you a little bit of a taste for it. Okay? That in that you have a special main that you can use just to test things and see how it works. Everybody good so far? All right. Questions? Concerns? Comments? Criticisms? Yes?
For our overloaded constructors, do we have to have both an overloaded constructor with the name and one that has both the name and weight?
Okay. So for this project, we have two different constructors, one that is a default constructor and one that actually takes the information about a particular refugee. The actual constructors that you write will vary depending on what class you're creating it and how you intend to use it. What I'm trying to show you through here is that there are multiple ways of doing it. For example, for this refugee class, we could create a refugee that has nothing, then set their last name, set their first name, set their age, set their gender, set their camp separately. Or we can just do it all at once by creating one with all that information in there. And those are kind of like the two extremes of how you can do it, and combinations of those. So, okay. Other questions? All right. So I think the person class here has outlived its usefulness. So we're going to take a 1 second or 1 minute break, stand up and stretch, and I'm going to start working on another class for us. So. Anybody need some candy? Uh-oh. Sorry. Pulling out randomly here. Drop that one. That's a good throw. No. Oh, wait, here's a Twix bar. Oh, that was cruel. Peanut M&Ms? Did you want that one? Almond Joy? Crunch? You know, this is the only class I really do it for because it's like a big class. And I know this class can be like confusing and tedious, and if I just talk for an hour and 50 minutes straight, you get like the first 5 minutes worth, and the rest is just watching time slowly advance glacially on the clock. By the way, I judge like when you all need a break by two things, like how slumped back your seats are and how often you look at the clock on the wall. Like the more little, like I notice these little glances over to the wall all the time. So if people are glancing a lot, it's time to just take a break. All right, so let's get back into it. We're going to look at a different class and a different class for a different purpose. In this class, what we're going to be in this class, in terms of like the class that we're writing instead of the class that we're sitting in, we're going to be looking at points. We're all familiar with Cartesian points. A point on a Cartesian plane, it has two items in it, which are x and y. And just for right now, we're not going to worry about floating point stuff. We're just going to make them integers because it's less typing to type int than double. Okay. All right. So when we have a class, we have particular methods in it. What type of methods do we have in a class? This should be review. We have what? Yes, we have, those are the different types of classes and data members. But for methods, what types of methods do we have? We'll need a constructor. What else? Yeah, we might need getters, which are called observers. And what else? Setters, which are called accessors. There's a chance I have those two backwards because I do that sometimes. Anything else? Destructors. Okay. All right. Now a few things. First of all, destructors are not always necessary. Okay? Destructors are not always necessary. We're going to use them in here just so we can demonstrate what's happening with particular things, but they are not always necessary. The only time that you absolutely need destructors is later. There are certain times when you need it that we haven't been introduced yet, so we'll need them later. And I just really cannot type destructor, can I? Okay. But we'll go ahead. Did I just mess it up anyway? Jesus. Maybe I should have been eating that candy myself. Okay. What does a destructor look like? Tilde and then what? Name of the class, and we're using capital. It is case sensitive, so. All right, how about a constructor? What does a constructor look like? Just the name of the class with what return type? None. Okay, it was a trick question. Okay, so we just have that. And for initializing a point, what values, what type of constructor might we want to have? Like, yeah, we might want to have one that takes 2 ints, right? So we might have one that just creates that doesn't really do anything. Actually, it does stuff, but doesn't take any arguments, or we might have one that has 2 ints. Okay? Sir? I'll show you. We'll get to that. Okay? We'll get to that. And in this case, we do want both. I will tell you, if you do not explicitly put a constructor like this in there, the compiler will create one for you. The compiler creates one that does nothing. Okay? So you definitely, if you need to initialize anything, You definitely need to write your own constructor. If you don't need to initialize anything, the compiler will create one for you. It'll be visible. It'll be the null constructor that does nothing. Same with destructor. You don't always need to put a destructor in. The compiler will create one for you. By default, it does nothing. Okay? That makes sense? So we'll take a look and see why we need these. So let's just go ahead and write these before we get too far ahead of ourselves. Okay? So we want to write I'm going to split the screen here so that we can kind of see what we're doing as we go along. So down here, we want to write the first constructor. How do we write a constructor? The name, like this, point, and then what? 2 colons, because the first one means it's part of the point class. The second one means this is the constructor for the point class. And the first one takes no arguments at all. Okay? Takes no arguments. So, what do we want to do inside this constructor? Initialize what? Okay. In here, we would like to initialize x and y to some known values. What happens if we do not initialize x and y? What values do they have? We don't know. We don't know. So if we chose not to write a constructor for this, and we allowed the compiler to put the constructor in for us, what would the constructor that the compiler put in do? It would do nothing. And so what would the values of x and y be if we used the default constructor that the compiler gave us? We would not know. Does that kind of answer your question? Okay. So this one, by default, when we create a point, it's going to appear at 0, 0, the origin. Okay? The other constructor that we're going to create takes some other data. This one will be used if we just want to create something and have it not start at 0, 0. Okay? So the other point constructor will start the same way. It'll say point : : meaning it belongs to the point class. It will be called point because it is the same name of the class, but it'll take a new x and a new y. Okay? And what do we do inside this constructor? We're actually trying to set it to something other than 0 and 0. Yep, new x and y equals what? Everybody with me so far? So we created these 2 constructors. This one, the first one is like the default constructor, because this is what gets called just if you create something, but still, sets to 0, 0. And this one sets to any point you want, right? Depending on what parameters you give it. So we have 2. It's good to have the default one, particularly if you have values that you need to initialize. We need to initialize ints. Yes? Uh-huh. It would not be able to change it. We're going to get to working with, like right now we're just looking at how one works. The next example we get into will be how these things interact with each other and how we can like manipulate things inside other objects. Okay, so we'll get to that. All right, so we're doing pretty well so far. What I'm also going to do, just for illustration purposes, I'm just going to print out what's happening in these constructors, okay? And is this normal to print out inside the constructors? Why am I doing it? Just for demo purposes. Watch this, we'll even make this really pretty. And we'll put the same printout down here. And now we can actually see when these points get created. Okay? All right, so let's go back. I'm just going to take a look at our class. We've created destructor, constructors. Destructor. Let's go ahead and create a destructor while we're here. So what does the destructor look like? Point, colon, colon, because it belongs to the point class. Tilde, point. Can the destructor take any parameters? I don't think so. I'd have to check on that, but it doesn't make sense to me that it would. Okay, and inside this destructor, what do we have to do? Nothing, right? We don't particularly have to do anything. Later in the semester, we'll see cases where we have to do stuff. And now what we'll say is we are destroying destroying points. All right, so we have some very minimal functionality in here. We can create a point, we can destroy a point, and they print out. Let's go ahead and test it and see if this is working. Does that sound like a good idea? How do we test this code in main? Make a point. And what point do you want it to be? All right, we're going to create a point, and we'll create a second point. And point 2, we're going to give some other values, like 5, 5. All right, so here's our algorithm. Create point with no parameters, create a point with some parameters, and stop the program. What do you expect to see to print out here? What do you expect this whole program to print out? Start at main, call the point 1. What method gets called here for point 1? Which constructor? The one with no parameters, so we expect to see 0, 0. It should print out new point at 0, 0. After that's done, it comes down to point 2, 5, 5. What does this do? Calls a constructor that has 2 parameters, 5 and 5. It should print new point at 5.5. And we say return 0, and then we reach the end of main. What happens after we go outside of main? Points 1 and 2 no longer exist. They've gone out of scope. Remember, variables only exist inside the curly brackets. They go out of scope. When they go out of scope, what happens? They get destroyed. And in general, but not always, maybe always, they get destroyed in the opposite order they were created. Okay? So we should see point 2 getting destroyed first, then point 1. So let's see if we actually have that or not. I hate when I do that. Sorry, I accidentally closed the editor. Okay, get that back. All right. All right, so here's the point class. We'll just compile that and make sure it works. So it compiled correctly, which is always good. Now let's see what happens when it runs. And we see what we just said. We see a new point at 0, 0, a new point at 5, 5, destroying the point at 5, 5, destroying the point at 0, 0. Nothing new so far, right? Sir?
If we don't make a destructor, what happens? It still goes out of
It still gets destroyed. It just gets destroyed automatically. There are cases, though, where you can create things that live after the destructor is called. And it's a problem. We'll get to that later in the semester. So, yeah. You need a destructor. We don't need it right now. I just want you to be familiar with what it's doing and when it happens, and then later we'll see actually why. And when I'm teaching this, I always struggle whether or not to teach the destructor right now or to teach it later when we actually have a use for it. This semester I've reversed it a little because last semester it was equally confusing. I don't know. Like I try to organize things so that like everything stacks on top of each other, but every once in a while there's like a piece that like one stacks on top of the other, but the other stacks on the other, and then there's just no good order to do it. And it makes me sad. So, and I end up giving you meta level lectures on how I organize a class. Yes? Yes. The basic premise is to clear up memory. There are instances where in an object you will create a lot of memory inside the object, and you need to get that memory back. That's the basic idea. there's another way, like right now we're getting memory by saying, please give me a person object, and it goes out and gets later there's going to be another way to get memory that you don't get back automatically. Okay. All right, more than you need to know right now, but that's where we're heading with it. Okay, so this is all very boring. We've all seen this before. Let's start doing some fun stuff with our points. What else can we do with our points? We can what? Well, I mean, we can change values, right? We could say something like set x, right? Like we might want to change the x value. What else might we want to do? Might want to change the y value. These are pretty exciting, aren't they? Except those aren't observers, they're setters. Okay. All right, so we'll run these through really fast. How do we set x and set y? If we want to create a method for this, what does it look like? All right, point set x, takes an int new x. And what do we do in here? Yep, pretty boring stuff, right? Yes? Yes. I was thinking that looked a little odd. Here. Say peanut butter cup award. I normally don't give those away. I save them for myself, but I've been eating too many of them. So, all right. So let's go back and put void up here as well. That's much better, actually. I had the inkling something was wrong, but okay. All right. And if we want to do y, how do we set y? Exactly the same way, except we make all the x's y's. And this is pretty tedious still, isn't it? All right, this is the sad part of object-oriented programming, is that a lot of the stuff you're doing is just kind of tedious and repetitive. However, I hope that you can see that what we're doing is we're taking a big problem, right, making concepts out of it and fixing, like in each one of these methods, doing some small part of the solution. And it's just a different way of breaking down the problem than we had before. All right, so now if we want, we should be able to do something like, anybody have a particular x coordinate they like? That's not 0. No favorites. 7. How about a y coordinate? 7, 7. Okay. So we're changing these coordinates. Let's compile it and see if it works. It compiles cleanly. Let's run it. Okay, so we saw a point was created at 0, 0, and we see one getting destroyed at 7, 7. So we did change something in there. But we don't want to have to wait until our object is destroyed to see what happened to it, did we? Because that would kind of suck. We create a whole object and then we destroy it to see if it worked or not. Doesn't make any sense. So what we need is we need some way of showing what a point is, don't we? So let's do something like this. We need an observer. And this observer, I'm just going to have it print, I'm going to call it draw. And draw is just going to print out the current point. Okay? So how do we create a draw method? Somebody yell out things for me to type. Void, yes. Point, because it belongs to the point class. Draw. And we'll just copy this stuff and put it over there. And then we'll say, instead of destroying, we'll say drawing. All right, and now we can go down to main, and after we set it, we can try and draw it and see if it worked. And we can say one dot draw. All right, so now what I've done is we've changed the set x, we've said set y, we've changed draw, and now we can compile it and see if it works. And it works. And we run it, we see a new point being created, another new point being created. Things get changed, and we're drawing the changed point, and then we're destroying the other points. Everybody good so far? Pretty straightforward stuff, right? Now, let's talk about doing something a little bit more. What can you actually do with points mathematically? You functions on them? Like what kind of function? What's a very simple function we could do with 2 points? Math? Some people are math majors, right? We're not getting the lines yet. Lines are way more complicated. We do need 2 points to get lines. And in fact, next class, we will look at how to build a line class out of points. But right now, we have other stuff we want to do with points. Like, why don't we be able to add 2 points? So what we want now is we want something that's called add. And the question is, what do we do? So what we're going to do is we're going to create a method. And it's going to look like this. We're going to take a point like this. We're going to add it to our current point, and we're going to return a brand new point that is the sum of the other 2 points. All right? So what we're starting to do now with our class is we're starting to add additional functionality. And in this case, for the point class, you're going to be able to add 2 points together and get a third point out. This is just like if we were adding 2 ints together and got a third int out. Okay. Everybody with me so far? And we will tackle that on next time, Tuesday. Today's Thursday, right? All right. I will see you next week on Tuesday. As a reminder, I don't have office hours today. Email me if you'd like to see me tomorrow or Monday. Have a good weekend. Get cracking on Project 4. Actually, I bet you have pretty much all you need to do Project 4 if you just crank it out over the weekend. So.